So the first thing we have to do is write an equation to model the distance the pirate ship is in motion in time.
So we use the information that is given to us. One of the first thing is to take an account of the max point, in which it says that it takes 4 seconds for it to reach to the top at a height of 40 feet. We are also given that it takes 2 seconds later to get to the minimum point, which is at 5 feet above the ground. Now that we have our information, we will begin to plot our points on the graph.
For convenience, we decided to make a graph in which the y-axis goes at a 5 feet per mark and the x-axis that goes 1 mark per second. And we begin to plot the points as given. As you can see, we have plotted the points but not have made the graph entirely. To finish the graph, we start by finding the amplitude. To find the amplitude, we simply do the max point minus the minimum point and divide it by 2. This is the formula. So we subtract 40 from 5 and we get 35. We now do 35 divided by 2 and get a total amplitude of 17.5. Our amplitude would be 17.5.
So now that we have found amplitude, we are now able to find the midpoint of the graph. To do this, we can either subtract the amplitude by the maximum point, or 40 feet minus the amplitude 17.5, or we can add the minimum point to the amplitude, in this case 17.5 plus 5. Either way of what path you choose, we will get the same number, and our total midpoint line number would be 22.5. This is important to figure out our equation. So after we found our midpoint, we can now find the frequency of our graph. To do this, we find a minimum or a maximum point and alternate it with its nearest partner, which is the minimum or the maximum point. We can only do it within the minimum and the maximum points individually. So let's say we take we can take this point on the graph and incorporate it with this point, and that will give us a period of 6 seconds. So now we can use the formula to find frequency, which is P equals 2 pi over B. Now we will substitute the letter P for 6 seconds and get the equation 6 seconds equals 2 pi over B. And now the whole point is to get B by itself. So what we did is use cross multiply, and we get a new equation, which would be 6b equals 2 pi. And now for the final step is divide by both sides and get b for frequency equals 2 pi over b, and our b would be 6 seconds. So now we can simply divide, and that gives us a total of 1.04. So that will be basically our frequency.
To accurately draw the graph, we have decided to find a midpoint in terms of x-axis within a minimum point and maximum point, and vice versa. We did this in order to calculate the shift of the graph as soon as it reaches the midpoint. A quick example is the first midpoint and the first maximum point. The first minimum point lies within 0 seconds at 5 feet. We can conclude, and the first max point lies at 4 seconds at 40 feet. We can conclude that the shift in graph is at 2 seconds for best accuracy. However, if you look at the relationship between the first max point and the second minimum point, the difference in time would be 2 seconds. Therefore, we can conclude that the shift in graph writing the first max point and second minimum point is at 5 seconds. With that being said, the graph can be made like so.
So now that we found all the parts to the equation, we can successfully make the equation. Usually the general formula for this type of function would be y equals a times f parentheses b parentheses t minus h close parentheses twice plus k. The k usually would be the midpoint, b would be the frequency, and a would be the amplitude. And so for the final part of our equation, we choose a midpoint, and we decided to go with the first midpoint, which lies right here. And so since it's going in an upward motion, we can describe it as a sine. So ultimately the equation would be like this: y equals 17.5, which is the amplitude, sine of parentheses b, which is a frequency, 1.04, and then another open parentheses, in this case it would be t. And so we have to find a variable for h, or a value, and the best value would be 2, since the h stands for the x-axis of the midpoint. So in this case it would be 2 minus 2 close parentheses, and do it again, plus k. In this case it would be 22.5. So this would ultimately be our equation for this graph.
Letter B. How far away is the pirate ship from the ground at 23.7 seconds? To do this, we use the previous equation that we found out. This would be y equals 17.5 sine, open parentheses, 1.04, open parentheses, t minus 2, close parentheses, plus 22.5. We can now substitute t with 23.7. T represents a certain time. We plug the equation into the calculator. The pirate ship is 12.95 feet away from the ground at 23.7 seconds. Letter C. When is the first time the pirate ship is 25 feet away from the ground? To do this, we start by inputting 25 within the equation. Y is replaced with the equation to get 25 equals 17.5 sine, open parentheses, 1.04, open parentheses, t minus 2, close parentheses, plus 22.5. The main goal is to get t by itself. We start by subtracting both sides by 22.5. We get 2.5 equals 17.5, open parentheses, 1.04, open parentheses, t minus 2, close parentheses. Next, we now divide 17.5 from both sides. We want to get rid of every variable. 2.5 divided by 17.5 would get us roughly 0.143. It would be modeled 0.143 equals sine, open parentheses, 1.04, open parentheses, t minus 2, close parentheses. To get rid of sine, we apply the same rules to any other variable. We do sine on both sides. Instead of doing sine of 1.143, we are going to do inverse sine of 0.143. The equation would be inverse sine of 0.143 equals 1.04 open parentheses t minus 2. The simplified is 1.43 equals 1.04 open parentheses t minus 2. We now divide 1.04 by both sides like so. The equation will now look like 1375 equals t minus 2. All we need to do is add 2 to both sides to get t equals 2.1375. The first time the pirate ship is at 25 feet is at 2.1375.
So letter D tells us when is the second time that the pirate ship is at 25 feet. To answer the question, we would need to change the shift of our equation. And since we started with sine, we would transition to our second midpoint, which lies right where I just pointed at. And so it's kind of confusing to some degree, but if we look at the midpoint, we can see that it is going at a downwards motion. As you can see, that would be the cosine of our equation. And so we can write it as 25 equals 17.5 cosine, open parentheses, 1.04, open parentheses, t minus, instead of the 2, we will look at the x-axis of the second minimum point, which is 5. In this case, it would be t minus 5 plus 22.5. And so, like the previous equation, we will start by getting rid of all the variables in order to get t by itself. So we subtract 22.5 from both sides, and we get 2.5 equals 17.5 cosine, open parentheses, 1.04 t minus 5, close parentheses. And then the next thing that we will do is divide 17.5 on both sides. So similar to the previous equation, it will be 0.143 equals cosine, open parentheses, 1.04, open parentheses, t minus 5. And now we start by getting rid of the cosine, and do it on both sides. So instead of doing regular cosine, we are going to do inverse cosine. It will be cosine of 0.143 equals 1.04, open parentheses, t minus 5, close parentheses. And so the equation for this would be our final equation would be 1.43 equals 1.04 equals t minus 5. And so we basically subtract from both sides, and we will ultimately get the new equation, which would be right here, and it would be 1.375 equals t minus 5. And then we just add on both sides to get a total, or our total answer would be 6.1375. And that is the answer to our letter D. And thanks for watching this video.